Hey guys, welcome to DataTrek, your one-stop channel for all the data science and machine learning updates. Companies are powering their production systems using generative AI. In the last video, we looked at 4 such applications. In this video, we will look at 4 other such applications. I will also add the link of the last video or part 1 in the description. So let's get started. The first example that we will see is QueryGPT from Uber. So what Uber has done in a nutshell, they have launched QueryGPT, with which the employees can write queries in simple English languages, which will be converted into SQL queries, executed, and results will be fetched and provided to the user. Let's get into more details and see how and what they implemented. So SQL is a vital tool used daily by engineers, operation managers, and data scientists at Uber to access and manipulate terabytes of data. QueryGPT uses large language models, vector databases, and similarity search to generate complex queries from English questions that are provided by the users as input. So basically converting simple English languages into SQL queries. And what was the motivation? At Uber, the data platform handles approximately 1.2 million interactive queries each month. The operations organizations, one of the largest user cohorts, contributes to about 36% of these queries. Authoring these queries generally requires a fair amount of time. So basically writing the queries takes a decent amount of time. Given that each query can take around 10 minutes to author, the introduction to QueryGPT, which can automate this process and generate the reliable queries in just about 3 minutes, represent a major productivity gain. So basically Uber has 1.2 million interactive queries each month, and writing the queries and fetching the results takes around 10 minutes. But now with QueryGPT, people will just write the query in simple English language and fetch the results using QueryGPT, which takes 3 minutes. So the time reduction from 10 minutes to 3 minutes is a significant gain, because it's for a large scale of about 1.2 million interactive queries. And how this idea came? QueryGPT originated as a proposal during Uber's Generative AI Hack Days in May 2023. So it was a part of hackathon idea. And they have described the current version of QueryGPT, and they have also told that it took them 20 plus iterations to get the current version of QueryGPT. The first version of QueryGPT relied on a fairly simple RAG to fetch the relevant samples we needed to include in our query generation call to the LLM. We would take the user's natural language prompt, vectorize it, and do a similarity search on the SQL samples and schemas to fetch 3 relevant tables and 7 relevant SQL samples. So what is a RAG? RAG is retrieval augmented generation, where to the LLM you pass the user input prompt as well as few more information, which is the private data of the company. So in this case, what they are sending is the English language prompt along with the 3 most relevant tables that has come from the vector search, which has come from the retrieval stage of the RAG. The 3 most relevant tables to this user query and 7 most relevant SQL samples to this user query, along with the user prompt, will be passed to an LLM to convert it into a SQL query. So that was the first initial Hack Day version. The first version used just 7 tier 1 tables and 20 SQL queries as our sample dataset to test out the POC. And how these tier 1 tables look like: this is the ubers.trip data, this is the table content. And to help LLM understand internal Uber lingo and work with Uber dataset, we also included some custom instruction in the LLM call. So basically in the prompt engineering, they also made sure that Uber internal lingos are understood by the LLM. And how would the response be? The response was expected to be in JSON format, where they would include both the SQL query and the explanation of how the LLM generated that query. So you can see here is the explanation and what is the final query. Select count star as number of trips from uber.trips, join with ubercity on ubercity.id with the dc.city id, and so on. So this is the SQL query, and why this SQL query was generated, this is the explanation. So the first version used a simple RAG. The user English query was enhanced with the 7 most relevant SQL samples and 3 most relevant tables, which came via vector search of user query with the private data, and this was then clubbed together and sent to the LLM along with some prompt engineering. So LLM understands the Uber's internal lingo to generate the SQL query along with the explanation. Then they enhanced the RAG system. They came up with a better RAG. Doing a simple similarity search for the user's natural language prompt on schema samples and SQL queries doesn't return relevant results. Here they are saying that doing a simple vector search was not returning very good results. So what they did, they wanted their system, their Query GPT, to understand the user intent. Another issue we found that it's incredibly challenging to go from a user's natural language prompt to finding the relevant schemas. We needed was an intermediate step which classifies the user prompt into an intent that maps the relevant schema and SQL samples. So directly understanding from the English language question to which tables to use is a tough problem. Instead of that, what they brought in between is the user intent, what user wants. So that was the first problem they wanted to solve, bringing the user intent. Another challenge was handling large schemas. Some tables were really big, so when they were clubbed together in the prompt would become very large. We have some really large schemas on some tier 1 tables at Uber with some spanning over 200 columns. Large tables could use up as much as 40 to 60,000 tokens in the request object. Having 3 or more of these tables would break the LLM call, since the largest available model at that time only supported 32,000 tokens. So another problem is that even if you have figured out the 3 most relevant tables, if those tables are very big, when clubbed in the prompt, it would break the token limit. So how they solve for these 2 problems? One is bringing the user intent into picture and then selecting the tables. And secondly, since tables are becoming very big, how to prune those tables and bring them in the prompt. These were the 2 main challenges which they solved it. And how they solved it, let's look into it. They introduced something called workspaces. In our current design, we introduced workspaces, which are curated collection of SQL samples and tables tailored to specific business domains such as ads, mobility, core services. These workspaces helps narrow the focus for the LLM, improving the relevance and accuracy of the generated queries. So basically they introduced something called workspaces. Workspaces would be something like the user is talking about ads or mobility or core services. What is the workspace? What is the intent they are talking about? So intent is getting mapped to workspace. We identified some of the most common business domains inside Uber and created those in the backend as system workspaces. And what is mobility workspace? Mobility workspace is the one that include queries about trips, driver, document details, etc. And along with this, they had 11 such workspaces, including core services, platform engineering, IT, ads, and so on. And we also included a feature that allows users to create custom workspaces. If they feel that one workspace doesn't have all the tables that they need, they can create some custom workspaces of all the tables that are relevant for their custom workspaces. So in this way, they solve the problem of intent. User will write the query in English language. Depending on that, a workspace will be selected. Workspace will already have the set of tables needed to answer that query, and then that will solve the problem of intent. They also have an intent agent. So what's the goal of intent agent? It's very simple, to identify the workspace. So what the intent agent does is, every incoming prompt from the user now first runs through an intent agent. The purpose of the intent agent is to map the user question to one or more business workspaces. The workspaces we saw already. The idea is that intent agent will map the user input to one of the workspaces. We use LLM to infer the intent. So intent agent is also an LLM agent. And picking a business domain allowed us to drastically narrow the search radius for REC. So in this way, the search radius reduced. They also have a table agent. So what table agent does is, allowing users to select the tables used in query generation came up as a feedback for some users who saw that tables that were eventually picked by QueryGPT were not correct. So basically they are saying intent agent has identified the workspaces, and within that workspace, let's say it has selected 4 tables, but to answer that query, one more table is needed. So table agent, what will it do is, it will select the tables within the workspace, and then it will be an editable list. It will ask the user that I am planning to use these tables for your query. The query was find the number of trips completed in Seattle yesterday. So it will tell that I am planning to use these 3 tables. Are you okay with this? The user may select look good, or user may add more tables. So there is a table agent within the workspace which select the relevant tables, and if some tables are missed out, the user has this editable option where they can include more tables. They also had one more agent. So there is an intent agent which identifies or maps the user query to workspace. There is a table agent which selects the table within the workspace, and also it's an editable list. And they also have a column prune agent. What column prune agent does is, even if the table is selected, table may have 200 columns, only some columns may be relevant depending on the user query, right? So column prune agent will do is, another interesting issue we ran out after rolling QueryGPT to a large set of users was the intermittent token size issue during query generation for some requests. We were using OpenAI GPT-4 Turbo with 128k tokens, but still some places, some request one or more tables that consume large amount of tokens will break this 128k k token limit as well. So we implemented column prune agent, which is again LLM agent, which will find that within those table which are the relevant columns and which are the irrelevant ones. So as a result of it, it will make the table thinner by only using the relevant columns, and once the relevant columns within a table are selected, and same thing is repeated for all the tables, then that information will be clubbed with user input to generate the SQL query, or the final query GPT task will be completed in that way. The output would include a Skinner version of each schema that we needed to query, that we needed for the query generation. And so that is how they implemented a query GPT. They have implemented a RAG, which first identifies the intent, that is the workspace. They have a table agent which selects the table within the workspace. They also have a column prune agent which within the table which prunes the columns and make the tables much more skinner. And how they evaluated the performance? They evaluated the performance using some standardized techniques, and which are very interesting. So they could have created a golden question to SQL answer mappings, but that would take a lot of time. So instead of that, what they did was, we identified a set of real questions from Query GPT logs and manually verified the correct intent, schemas required to answer the question, and the golden SQL. So how they did that? They have come up with a bunch of evaluation schemes, and this evaluation scheme is designed in such a way that different steps of Query GPT, which is intent agent, table agent, column prune agent, we can identify that what is the accuracy of each intermediate step. So what they do is, they first identify the intent. Is intent accurate or not? Is the workspace selected correct or not? Table overlap is, once the workspace is selected, are the right tables selected or not? If they've explained here that if only 50% of the tables are correct, then score will be 0.5. So they next check is, within the workspace right tables are selected or not. Was the query run successful or not? If the query run had an output or not, the query return greater than 0 records or not. And also the qualitative query similarity, how similar this query was with the golden SQL, which is the actual SQL for that task. So in this way, they evaluated all the intermediate steps of the Query GPT: intent, table overlap, successful run or not, run as an output or not, and how close the final query is with the golden query. And some of the limitations that they have explained, that LLMs are non-deterministic. The same question you ask again, because of the probabilistic nature, it may give a slightly different answer. So in general, we do not over-index our decision on the metrics, and we assume that 5% the metrics will change on run-to-run basis. Some of the learnings they had: first was RAG improved their accuracy. Another learning was the intent agent, table agent, and column prune agent each did an excellent job, because they were just asked to do a single unit of work rather than a broad generalized task. So breaking the task of Query GPT into table agent, intent agent, column agent worked wonder, because each agent was just solving for one of the problems. Another issue that is very common with LLMs, and even they faced, was hallucinations. The hallucination is, this remains an area where we constantly working on, but in a nutshell, we do see instances where a LLM would generate a query with tables that don't exist, or with columns that don't exist. So this is the hallucinations, where LLM is hallucinating. And they have some interesting ideas to solve for hallucinations as well. We have been experimenting with prompt to reduce hallucinations, introduced the chat style mode where users can iterate on the generated query, and we are also looking to implement a validation agent that will recursively try to fix hallucinations. So there can be validation agent as well, which will see that the final SQL query is hallucinating or it's correct. If it's hallucinating, it may try the process again, because LLMs are probabilistic in nature, or with some small tweak in prompts here and there, it may generate the right query. So that's it. The conclusion is, the development of Query GPT at Uber has been a transformative journey, significantly enhancing productivity and efficiency in generating SQL queries. Query GPT seamlessly integrates Uber's extensive data ecosystem, reducing query authoring time and improving accuracy, addressing both the scale and complexity of their data needs. While challenges such as handling large schema, reducing hallucination persist, the iterative approach and constant learning have enabled continuous improvement. Query GPT not only simplifies data access but also democratizes it, making powerful data insights more accessible across various teams in Uber. And what are the benefits? With our limited release to some teams in operations and support, we are averaging about 300 daily active users, with about 78% saying that the generated queries have reduced the amount of time they would spend authoring them. You can read more details about this blog. I will add the link of this blog in the description section. With that, let's move to the next production system of a company where they have implemented genai, that is Yelp. So this is the blog from Yelp. I will add the link of this blog also in the description section. What Yelp does, Yelp is in a mission to connect consumers with great local businesses by giving them access to reliable and useful informations. Customer trust is one of their top priorities, which is why they have made significant investment in technology and human moderation to protect the integrity and quality of content on Yelp. So Yelp provides information, ratings and reviews about local businesses. So reviews are very critical and they have to go through human moderation and lot of review before the reviews are accessible to the people. Yelp has recently enhanced the technology stack by deploying LLMs to help surface or identify egregious instance of threats, harassments, lewdness, personal attacks or hate speech. So this kind of reviews having threats, harassments, lewdness, personal attacks or hate speeches needs to be flagged and removed from the platform. Why they have used LLMs for inappropriate content detection? Automating inappropriate content detection in reviews is a complex task. Potential complexity of different contexts, several considerations go into creating a tool that can confidently flag content violating their policies, and this could be instances of threat, harassment, lewdness, personal attack or hate speech. So many complexities, it becomes hard to detect such reviews. Addressing this, they have iterated through several approaches to achieve higher precision and recall in the detection of inappropriate content. The trade-offs in precision recall drove them to adopt LLMs, which have been largely successful in the field of natural language processing. They explored the efficacy of LLMs to identify egregious content such as hate speech, lewdness, threat, harassment or extreme forms of personal attacks. So what they did was, you can read the blog for more details, but what they did was they downloaded LLMs from Hugging Face Model Hub and used the embeddings. They converted the reviews into embeddings, and they saw that with those embeddings they were very well able to classify the inappropriate samples with the appropriate ones, and hence they used LLM embeddings which they downloaded from the Hugging Face Hub to enhance or fine-tune their review classifier. So you can read the blog for more details. The main intent was to give you an idea how companies are using genai to power their systems. We will move to the next interesting problem statement, which is from Vimeo, how they have implemented genai in their production system. So I will add the link of this blog also in the description section. So Vimeo is a video hosting, sharing and streaming platform tailored for creators and businesses to showcase, distribute and monetize high quality video content. So creators can upload and share their videos over Vimeo. And Vimeo have deeply invested in their technology. They have recently launched several AI powered features that dramatically reduce the barriers of creating and editing videos, enabling anyone to record in one take and edit in seconds. This article explores a project at Vimeo where the primary scope was to test and demonstrate the power of generative AI. Specifically, this took the form of a help desk chat prototype that combines AI technology with the knowledge found in Vimeo's help center articles to improve customer support with efficient, useful and personalized answers to questions. So basically, Vimeo has this help center where users can search for something they are looking for. For example, if they are looking for how to embed a video to their domain, this kind of results will come. All the pages where they have explained what to do will come out as a output on searching that. Today, customers with an issue or question about Vimeo have few options. Either they can open a ticket with Vimeo support team, or they can search for related articles. When they search for something, the related articles will come up. And this thing is handled by a third-party platform to understand the intent of a question, and based on that either provide guided workflow or specific answer passed from existing help content. So third party is handling it, where if someone searches something, some results will come, or they can open a ticket with them, which is not very user friendly. And same issue I have faced with Instagram when I am looking for something like how to deactivate my account, or how to make my account private, or how to download my private information. I have to first look at some YouTube video or go to Instagram setting and look for multiple options till I found the thing that I'm looking for. This kind of problem is very genuine and happens with many platforms. I personally found it in Instagram as well. And the problem that is there in Instagram or such platforms can be solved with what Vimeo did. So Vimeo also had this problem. User would want to search something, they will write it, and a lot of pages will come up that you can find such information in these pages. So what Vimeo did, this information is there, right? In the pages, in the help centers, in some form of documentation is there. What they did was they powered this information in a RAG-based system, retrieval augmented generation system. So what Vimeo did was they implemented a RAG-based system. Vimeo's prototype bot has the potential to improve an experience like this by leveraging the latest in generative AI. Specifically, by integrating AI technology with our existing resources, we can develop a more responsive and effective support system where customers input their questions and receive immediate, accurate and helpful responses. So basically the question was, how can I domain restrict embeds? Previously some of the pages were coming up that you can find those information in these pages, but now they have implemented a RAG based system, retrieval augmented generation system. Given the user query, most relevant articles will be fetched, they will be passed to LLM along with the user question to find the exact condensed result, and this is what the LLM will return in results, a condensed information exactly what search user is looking for. To domain restrict embeds, you can go to your video edit page and click privacy on the right side of the page. Under the embed section, open the drop down menu where can the video be embedded and select specific domains. And also to find this condensed exact information, these are the pages which were used as references. So basically what they did was, previously when the user was asking a question, relevant documents will come up, which was again a tricky task to go through document, find exactly what the user wants. Now that information is passed as a RAG system, retrieval augmented generation system. The most relevant documents are passed to LLM along with user input query to find the relevant condensed information what user is looking for. And they have explained that they have indexed all their articles in vector store, and when the user query comes, the most relevant documents are retrieved using a vector search. And they have used LangChain library to implement their RAG. They have used conversational retrieval QA chain. They have used conversational retrieval QA chain because this chain from LangChain to implement RAG, and also this has a memory. It can maintain that contextual nature, that what was discussed just in the last chat and what is the follow-up question and so on. So that's why they have implemented this conversational retrieval QA chain of LangChain. I have also myself implemented a RAG on a company's private dataset. I will add the link of that video in the description section as well, and you can go through this blog. Again, the intent was to give you an idea that how companies are implementing this generative AI solution in their production systems. And I have personally found that this kind of implementation will be very helpful for Instagram and other platforms as well, where it becomes very tricky sometimes to search for something in the settings. Settings will have a lot of options and it becomes very tricky to find that option we are looking for. But if such kind of condensed information through a RAG based system is there, it will make the user's life easier and very user friendly. Lastly, but not the least, we will look at one of the blogs from Instacart, how they have used generative AI images to make their platform more visually appealing. So let's look in more details. This is the blog. I will add the link again in the description section. Instacart equips grocers with sophisticated digital tools to streamline their operations. And yes, AI has significantly enhanced these tools. They have order management system called FoodStorm. So what Instacart does is they have some freshly made food available for the buyers, like freshly made sandwiches or sliced deli meats, personalized cakes, or you can think of ice creams. All these things are customizable. For example, in sandwich, the bread is customizable to classic white, sourdough, multigrain, artisan roll. And again, sandwich, the top up can be meat, toppings, and so on. So there are so many customizations possible. And same with ice cream. Ice cream can come in different flavors and so on. So for these customizable options, either you can just have a text description, which is not very user friendly, or you can have the images, which makes it visually appealing and user friendly, making it easier for the user to make a decision. Now for these images, the problem is that an ongoing bugbear about grocer faces sourcing images for every possible product configuration. High quality food photography is crucial for online shopping, elevating the customer experience. This is where generative AI comes in. So basically, for all these customizable options, if images are sourced, there are two problems. One is the grocer will have to click and upload the photographs, or if they use some photographs from the internet, there can be copyright issue. So instead of that, we can use generative AI images for this kind of customizable products. And they've also told that it's essential to clarify that nothing can replace the authenticity of professional photographs showing the real product. However, for visualizing various fillings, toppings, and sides, generative AI can be of huge help. Our tests show that AI excels at creating these images. Think perfectly diced onions, finely shredded lettuce, or just the right amount of strawberry jam. So see, these are the flavors, toppings. For these generative AI images can be used. And the platform is created in such a way that they will have a lot of images generated, and the grocer can select which image they want to finally select, and so on. So you can read the blog for more details. This is an interesting use case where they have used generative AI images for their production system. So with that, we come to the end of this video where we looked at Query GPT from Uber, which converts English languages into SQL queries, and many interesting optimizations they had done. We also looked at Yelp's LLM classifier. What they do is they use LLMs embeddings so that they can better classify the inappropriate comments or reviews and remove them from the platform. We also looked at Vimeo's RAG implementation, which made the feature user is looking for, that search, very easy. They can get the exact information what they are looking for, where they can find in the platform. And lastly but not the least, we also looked at Instacart, where they have used generative AI images to make their platform more visually appealing. Hope you liked the video. Please like and subscribe and stay tuned for more such updates. Bye.